Assalamu alaikum. So in our last lecture, we were discussing about the ROLAP issues, and the main point here was to actually that when we have multiple dimension tables and we have some fact tables, and when we want to get all the summaries from the data, so as the number of dimensions are increasing, the number of summary tables will also increase. And similarly, when the summary tables will increase, we need more storage space to actually store those summary tables on hard drive. Now again we discuss one or two issues that were relating to maintenance of the summary tables. Again, the summary table should not be small enough that it does not hold uh, any number of rows that are uh, not good for data analysis. And the other thing was that the summary table should be maintained in such a way that each possible update should be applied to all the aggregate that were previously calculated. So it means that if a week uh, a summary table based on a week calculation is stored, each day's calculation should be passed on to actually updated inside that week's summary table. Now the another big issue is with ROLAP is that there can be multiple summary tables at different hierarchies of dimensions. Let's say we talk about again time dimension. When we talk, let's say that we want to store the products category sales based on a daily basis. It means that the sales of each product category will be recorded daily. So there will be different rows for each product category according to a single day. Let's say we say that on 20th of June of 1996, the product categories soda drinks had this number of sales, and product category juices had this number of sales. Again, on the next day, on 21st of June, we will have to record these two product category sales for the 21st June, again for this 23rd June. And let's say we say that we do not record the sales according to category, but we record the sales according to the product items. Let's say we talk about orange juice, we talk about Coca-Cola, we talk about 7 Up. And now on each day, some of the products might not sell. So the ideal case is if we have 7 products, each day each product sells and its entry comes inside a data warehouse. But on a worst case, there are 1 or 2 products that are sold on that particular day. The other remaining products do not sell on a particular day. So it means, let's say on 21st June, all 7 products were sold and their quantity and their sales were recorded in 20th June data, and on 21st of June, uh, the weather was cold and no products were sold. So there were or a single product was sold out of 7. So one single entry for that product will come into the data warehouse. Other products entry will not come into the data warehouse for 21st June. And we have another summary table that records the sales for a week. Now let's say we say that uh, the week the table that is storing products information on weekly basis, it is smaller than the summary table that is storing the detail of products on daily basis, because on daily basis the entries will come on daily basis, but on for a week the entry will come after a week. Now using this information, we can say that the week summary table is smaller than or less detailed than the daily table. So the coarser granularity, the word coarser granularity means that uh, we have a less detailed table than a more detailed table. Let's say weak summary table is a table that is based upon coarser granularity. It means it contains less information or high information or abstract information that is based upon weekly information, and uh, the summary table based upon daily basis is based upon the more detailed information. The information is more granular in daily summary table, but it is coarser granular in our weak table. So again, the meaning of coarser granularity is the storage of information in a less detailed format is called coarser granularity. And in course, when we uh, uh, store less detailed information inside a table, the number of rows also decreases. So the potential cardinality is, it means that number of rows. So it means when we have less, so the total meaning of this statement is that when we have less detailed information inside a table, the number of rows inside that table are less. Similarly, we can take the example of week summary table and year summary table. Year summary table will have a sales for a whole year, and it will have only one record. But if we talk about the weekly sales for all the products, it will have weekly sales of all the products. So the number of rows in weekly table will be more, but number of rows inside a single year in another table will have only one row for the whole year, which will contain the sales of all the products in the whole year. So it means that when we have lesser information or less detailed information inside a table, the number of rows are very little in that table. Now, based upon this statement, the data warehouse builder will actually decide uh, how much level of information or level of or how much granularity uh, I should have in my data warehouse. It means that at which level of detail I should store in my data warehouse. Of course, we need the CEO needs more less detailed information, which is actually the summary, and more detailed information like daily information. Should it be stored inside a data warehouse or not? Again, it depends upon how you analyze the data. So again based upon the above statement, we can say that aggregating whatever that can be aggregated. So if we combine all the hierarchies of a dimension, and we can get all the combination, and we can store all the summaries of that combination, we can store inside a data warehouse. Again, the main issue with that is that we will have to make storage available for that kind of combination. Again, the third statement is saying throwing away the detailed data after aggregation. Again, the whole point of this slide is that how much level of detail information that we can store inside our data warehouse, because on based upon our detailed information we get the lesser information or less detailed information. Again, it is saying that after applying all the aggregates on the detailed information, we should throw the details information. No, of course we should not, in a data warehouse environment we should not throw all the detailed information after using it, because maybe after 2 years or 3 years we need that information again. Let's say some scenario comes and we need that information again, so we have to pull that detailed information out of the data warehouse to actually get the aggregates again, because somehow in cases some aggregates are some, let's say our storage corrupts and our pre-calculated aggregated results are corrupt, so we need to actually get that data again, detailed data again, to again compute the aggregates. So again, it depends upon that how much level of information you want to store inside the data. Now, the rule of thumb is that if a detailed table uh, has some rows, and the lesser detailed table, let's say in our weekly basis, if we talk about a weeks sorry yeah, in our daily basis of summary table, we store products information daily. So we will have let's say we have 7 products, so we will store 7 entries of each product for each day. And let's say we talk about a week, so in a daily basis we will store these 7 entries for each day. So we'll have 7 into 7, 49 entries into a daily into the daily summaries table. But of course, I discussed earlier, some of the product do not sell on each day. So on average, let's say we have the detail table with the size of 30 rows. And on a weekly basis, we will actually get the computed results from the detail table. So the in 30s table, sorry, so in 7 weeks, the 7 entries for each day will bring 1 week out of that. So we will store all the computed sum from the daily table to the weekly table. So the weekly table is lot lesser than the detail, so daily summary table. So the rule of thumb is that if the lesser detail table is 10 times more uh, lesser than the uh, detail table, then we can actually we need to actually store that summary table inside our data warehouse. Otherwise we do not need to store that information, because we actually and the second thing is how this it depends upon the higher management, how much level of granularity or how much uh, level information they want to see. Mostly the CEOs do not look at the daily information, but they are more interested in yearly information or the quarterly information. So we have to actually see that if lesser detailed information table or summary table is 10 times lesser than the more detailed table, then we need to put that summary table inside a data warehouse. Of course, it is not a rule, it is not a law or a rule, but it is a general guideline. So uh, again, based upon our previous discussions, the whole point is that number of summary table increase with increasing number of dimensions, and some of the summary tables are not used in our data analysis. So how can we reduce summary tables? So many ROLAP products have developed means to reduce the number of summary tables by building summaries on the fly as required by the end user application. Now the whole point of this is we do not calculate the summaries in advance, but actually we calculate summaries on the fly or at the runtime. Uh, the summaries that are required by CEO that are being generating on the runtime. The other point is enhancing performance on common queries at the cursor granularity. So it means that we actually uh, we first pre-calculate all the lesser detailed data and store it into a data warehouse. So it actually increases performance, because we do not need to actually calculate all the summaries at the runtime, but all the summaries or lesser detailed information is already available in the data warehouse, providing smart tools to assist DBS in selecting the best aggregation to build. So there are different tools available that helps a DB or a data warehouse developer to actually tell him that you can actually build this aggregate summary table, or you do not need to build this kind of summary table. So in that thing, they have to actually trade off between two things, speed and space. So what does space does in a roll-up environment? If we have multiple summary tables, then you need more space, and if you have lesser space, then you have to calculate that uh, summary table on runtime. When you calculate those things on runtime, you will get lesser performance, because while calculating summaries from a larger or more detailed data, there is a lot of time required to actually calculate all the results at the runtime. So DBA has to make trade-off between speed and space. So he will see that how many summary tables I can store in advance before the analysis is done, and how many summary table I can build on runtime. So he will have to trade off between speed and space. So what maximum performance boost employs using a lot of disk space for storing every pre-calculation. So it means that if you want the maximum performance, you will have to calculate all the pre-aggregate results before analyzing the data, before the CEO analyzes data. So it means that you will have need to have more storage space so that you can calculate all the pre-aggregated results from the data and store it inside a data warehouse. But minimum performance boost implies no disk space with zero per pre-calculation. Now, if you want minimum performance, yani, it means that if you do not want performance, but sorry, so when you want you compromise on performance, actually it means that you will make all the calculation on runtime. So it means that you do not need to actually pre-calculate all the results and store it into a data warehouse or in a in a disk. But when you will need those calculation, you will actually perform those calculations at the runtime, and you will when you will perform the calculation at the runtime, you will your query performance will be very low. Again this depends upon how the DBA or the CEO wants to get all the results. If the CEO is very strict and wants a result at the same at the very moment he asks for it, he will you will have to choose space over performance. And if the CEO is very lenient, he can if he has ordered the analysis now and he wants to get the results on the next day, then we will choose performance over space. So this the developer or the DBA will have to make compromise again on space or performance based upon its organization's policy. Again, using metadata to determine the best level of pre-aggregation from which all the aggregates can be computed. Again, the whole point of this thing is that when we talk about the trade-off between space and performance, so uh, actually we go towards the coarser granularity. What is the coarser granularity? Actually we store some of the summary tables that are less detailed, and using those less detailed information we can actually compute all other information from that table. So it means that let's say we store the item sales quarterly base in data warehouse, but when we talk about yearly basis, that yearly summary table is not stored in the data warehouse. So when you need the yearly summary table or yearly calculation, you can actually compute the results based upon your quarterly summary table. Similarly, what will you have to do? You have to simply add all the quarters information of an year and you put that into another summary table at the runtime. So it means that you will bear lesser performance and you will actually trade off on the space. So you have if you have average space, you can trade off between space and performance, and you can store the data in a coarser granular form. Again, if you do not understand coarser granularity, I will discuss it that coarser granularity is storing less detailed information in a summary table, and its example is that the sales of a product or products on daily basis is a more detailed information. The sales of products on a weekly basis is less detailed information. Again, the sales of products on monthly basis is a more less detailed information. And again, the sales of products on quarterly basis is also a less detailed information. So it depends upon your company's policy that how much granularity, coarser granularity you want to store inside your data warehouse. So if we look at the graph, on the x-axis you have the space, and on the y-axis you have the performance percentage. It is showing that when you uh, occupy less space, you will have less performance. Again, when you occupy less space, you have to actually perform multiple queries at the runtime, and when you perform multiple queries at the runtime, you will let lesser performance. But as your space grows, your performance is also growing, and your performance now mostly you will get 80% of the performance at when you reach at the 8 MB. Actually, when you read the 6 MB, you are getting mostly of the 80% of the performance. So let's say you have total 8 MB space. On 8 MB you will get mostly 80% of the performance, because some of the calculation you very little calculation will also come into a lesser performance, but 80% is a very good performance for a query. So this slide is saying that when you're using lesser space, your performance is very minimum, but when you are using more space, again your performance is also increasing. So it means that with increasing number of with increasing space, you are actually storing the data. Actually you are storing the pre-calculated results on hard disk, and all you need at the runtime is to actually select the data from the database, from the from the hard disk, and bring it to the RAM to actually show it into the output. So again, the purpose of this whole slide is that with the with increasing space, your performance also increases, but when you have minimum space, your performance decreases. So you have to trade off between space and the performance issue. Now all we discuss till now, we discuss about MOLAP and ROLAP, and what is the MOLAP technique, what are the issues with MOLAP. Again we discuss about ROLAP and what is the issue with ROLAP, and how can we handle those performance and speed trade-offs. Now there are two different techniques that are left, which is HOLAP and DOLAP. HOLAP is hybrid OLAP, which is a combination of MOLAP and ROLAP. So target is to get the best of both worlds. HOLAP, hybrid OLAP, allows coexistence of pre-built MOLAP cubes along with the relational OLAP or ROLAP structure. Now how can we achieve this? We can achieve this by using ROLAP structure. What is a ROLAP structure? ROLAP structure is built based upon facts and dimensions, and then in ROLAP we actually calculate summaries and store it into the data warehouse. Now what we can do here, we can actually use the structure of ROLAP, and before calculating the summaries, actually we can build cubes on the using the MOLAP technique. Now MOLAP technique actually does not store the data on a disk, but it actually calculates the results based upon the data on runtime and build cubes on that data. So it means ROLAP is using the structure of ROLAP, but it's using the calculation of MOLAP to actually build the cubes. So how much to be pre-built I discussed earlier. The HOLAP can use the structure of ROLAP and use the calculation of MOLAP to actually build the HOLAP. So what is a DOLAP? Our desktop OLAP is that desktop OLAP is a cube that is actually built in an organization, but you can download some part of that cube into a desktop or in a mobile, so that you can use the processing speed of a desktop PC to actually monitor all the analysis in that DOLAP. Now now the whole cube is actually built upon multiple departments of our organization. Now a single department's manager can download its own cubes part on its own laptop or on desktop computer, and he can actually analyze the data, that how can he increase the profit of its own department. So again DOLAP, so again this thing is saying the subset of the cube is transferred to the local machine. Now the processing power of the local machine is used to actually analyze the data, but not the actually the server that was used to build the whole cube. So this was all about different online analytical processing techniques. We discussed about MOLAP, we discussed about ROLAP, and in the end we discussed about the HOLAP and another technique, which was DOLAP, in which we actually download some of part of the cube in our machine, and we do the analysis. So in our next lecture we will start discussing about dimensional modeling. What is dimensional modeling? Again, for a quick start, the dimensional modeling is just like an ERD that we prepare for a single database, but in a data warehouse environment we actually talk about facts and dimensions. So in dimensional modeling we will see how can we prepare dimensions and how can we prepare facts and how can we join these two different terminologies in a dimension model, so that we can actually design our data warehouse and how can we generate summaries from that data warehouse. Thank you.